Hello and welcome to our final FEDD project presentation. We are the Bridge Boys and our project is a collapsible bridge. So our first thought when designing a collapsible bridge was to look at the engineering design cycle, which consists of asking, imagining, planning, creating, and improving. We had to ask ourselves, what do we need to accomplish?
Here is a list of requirements and constraints that we had to meet. A few of the difficult ones were that it must fit into a 1-foot cube, hold at least 60 pounds, mustn't exceed a weight of 5 pounds, and a $40 budget. We had to imagine what our bridge was going to look like. We decided to model the shape of our bridge using a parabola, and we used calculus to find the arc length of the bridge, and we used the arc length of the bridge to determine what the final weight of the bridge would be. We skipped the creating phase and went straight to the improvement phase because we decided that an arch bridge was not going to work with us. This design was extremely common at FEDD and would not show any creative design. Here's the final design that we landed on, the scissor bridge. It is basically a scissor lift flipped on its side. Here's a photo of our bridge completely collapsed. Here's a photo of our bridge completely expanded.
We had many challenges throughout FEDD. Some of our biggest ones were finding tools, material selection, and being precise enough with our own construction process. The tools that were used were not accurate enough to measure exactly what we needed, and this caused us to be consistently about 1/8 inch off from our desired goal in many measurements throughout the building phase. Although deciding what material to use was difficult because we had to find a good balance between strength and weight management, meaning a strong material tended to be extremely heavy like steel, and extremely light material like balsa wood would lack the strength to succeed in our building bridge design. Also, because of price constraints, extremely high materials like carbon fiber and fiberglass were out of the question as they were too expensive for our budget. The impreciseness of our construction process is due to the fact that our group was constrained to hand tools and no machining of our parts. Here is our timeline for completing our bridge design, manufacturing, and testing of our bridge. As you can see, we finished on time and very fast.
To start, if we could do anything differently about our FEDD project, we would use better tools and more accurate measurement devices. We would also utilize the many workshop areas that are around campus, as well as the Aerospace and Mechanical Engineering Jet Propulsion Laboratory, which would have the right tools for the job. Some of our advice for freshmen would include don't be afraid to try new materials or ideas. As you can see, with our bridge design, we went very bold design. Our bridge design was on a league of its own in all of FEDD. Our materials were more common, but most groups still used wood. Also, style points will get you nowhere. At the end of the day, keep that in mind with new ideas, because style point is not on the rubric. Make sure to test your bridge thoroughly before competition, and try to bend as many rules as possible. You want to be that group that they end up making a rule for in the future, where they say they ban something because you did that. Here's our picture of our collapsed bridge after testing on FEDD Day. It got very bent, but as you can see, it's still a bridge.
Bring those sheets to the main competition area in room 1. Bring those final joints towards the main completion area of
You got bridge boys. Hold it this side off there.
For the results of our FED project, we were DQ'd due to the fact that our bridge was 0.2 inches higher than it needed to be. This was because of our inaccurate measuring tools.